Last time we also ever learned about the exoendothermic area. The energy changes, remember? Profile diagram. What chapter you learning at school now?
We just finished the
That's not right.
clusters. We just finished the clusters. We haven't have any chem class.
Oh, okay.
The scores are out already, sir.
Sorry?
The scores are out. I'm so disappointed in myself.
The scores are out?
Yeah.
Oh.
Sorry, you get?
So for paper 1, I got perfect, but for paper 2, I got 1 mistake. Sorry, sir.
Alah.
Useless piece of shit.
Tak solo ya kan?
Memang that low. 1 mistake so low, yo.
Okay, so this is the energy profile diagram. So the left side, still remember what's you, right? This one's to be the reactants, right? This one's supposed to be the products, right? So if from the reactants to the product, if you draw an arrow, the difference is being called as the enthalpy change, right? So in this case, the enthalpy change is positive or negative?
Positive.
Positive, right? So means this is endothermic reaction. Activation of energy. So remember which one is the activation energy?
The code.
From the reactants to the highest peak, right? So what is the definition of activation energy?
The least amount of energy to activate the reaction. Stop the reaction.
Least amount of energy to start the chemical reaction is known as activation energy. So for some chemical reactions, we need to do heating because you have to increase the amount of energy. Because the activation energy, the energy is not enough, doesn't meet the activation energy requirement, that's why it cannot react. So if I draw a exothermic reaction, so remember how the exothermic diagram looks like.
The product is lower than the reactants.
So the sketch, the rough sketch is like reactants.
I the same with you, Daddy. One mistake.
What?
Then is for endothermic, right? Now this is for exothermic. For the energy profile diagram, any of you have questions?
Nope.
I've learned this already. So if no questions, I'm gonna clear the board. Now we go to calculation. So to calculate the enthalpy change, we have to take the enthalpy change of the reactants minus the enthalpy change of what?
Products.
Products. Yeah. So for example, let's say like CH4 plus O2, right? Become a CO2 plus H2O, right? CO2 H2O. So let's say I say the bond of CH is X the value, then bond of O and O is Y. CO is A, HO is B. Okay, so before I calculate, I want to ask you or remind you again. For bond breaking, the value is always positive, right? It's the endo. For bond forming,
Negative.
the value is always negative. This is the exo. So if the question asks you, what bond is broken, it means the answer have to be CH, right? Or O and O. So remember, if I ask you what bond is formed,
CO, HO.
CO
HO.
or HO, we don't write the compounds, so I have to write the bond that's being formed. And now to answer the enthalpy change, right, we start with the reactance fraction. So the enthalpy change of the reactants. How many CH do we have?
How many words?
4. How many O2 do we have? 2. So the enthalpy change for the reactant is 4x plus 2y. Equations.
No.
The enthalpy change of the product is
2A.
2CO. So 2A plus what? 4.
2B.
4B. Understand why 4B?
HO times 2.
How many mole are there? There are 2 moles, right? So 2 times 2, so 4. So it means to count the enthalpy change, we take 4x plus 2y minus 2a plus 4b. Now if it's XO means your enthalpy change at the bond forming is greater than the enthalpy change
Of the one.
of the bond breaking. So you have to write this down as the reason. To explain is it positive or negative. So do you have any questions until here? No, the number all y4, y2, you understand or not? I know we have learned this, so I just revise before I give you the exercise because I mix the speed of reaction and the rate of reaction together. If you want to take a picture, maybe you can take a picture of it first again. If you already have, yeah, it's fine already. Can you give me the example of an exo reaction? Combustion, neutralization, bursting. Those are all exo, right? Example of endo,
Thermal decomposition.
photosynthesis,
Thermal decomposition.
thermal decomposition.
That's all I know.
Okay. Now continue again. Ever heard the term catalyst?
Yes.
So catalyst, the function is to speed up the chemical reaction
That'll be used up.
by providing a alternative route with a lower amount of activation energy. What does it mean? We'll go back to the sketch version. Now, if we use a catalyst, the catalyst will provide a path taken. So the path is different with a lower amount of activation of energy. So the activation energy becomes lesser. That's why it's more likely to react, easier to react. So the term is alternative route or alternative path taken. You understand? For the function of catalyst until here. Enzymes. What is enzymes?
Biological catalyst.
That's why you have to add again, without not being used up. So catalyst won't be used up. So enzymes, if you take GCSE exam, you have to mention this as a biological
Catalyst.
Sorry, students.
catalyst. Oh, anyone have questions until here? No, you want to take a picture? How does the catalyst work? How does an enzyme or a catalyst work? Do you ever know like enzymes work based on a key lock and key system? So means one enzymes only can work as one substance, right? One enzymes only can work as one substance, right? Any of you want to ask questions so far until here? No. Last week we learned about equilibrium, right? Or you can say dynamic equilibrium. So what are the two condition equilibrium? Well, for sure you have to be in a closed system, right? So in a closed system, the rate of forward reaction is equal to rate of backward reaction. Then the second point is that the concentration of the reactants and the concentration of the product remains
Same.
constant, right? So last week I don't bring it I don't bring it to the complicated term here. So the scientists that suggest this, right? Anyone speak French? I cannot read this. And I don't even bother to check Google how to read this. Okay, so based on this guy principle, if a dynamic equilibrium if you know how to read it, then it's good. It's weird for me to speak French. Or thought his statement version. Dennis there?
EA.
So you stay right. The dynamic equilibrium is distributed by changing the condition. It's changing it. Changing the condition and the position of equilibrium move to counteract the change. Just make it simple. So equilibrium means last week we say like the arrow shaft to where? Because the reaction must go forward, could be able to go forward and could be able to go backward. So if last week we discussed, for example, I say number one, if the concentration of A increase, equilibrium will shift to where? To counterbalance this. If you increase A, it's heavier on the left side, right? You understand what I'm asking? If we increase A, it will heavier on the left side. So where should the equilibrium go? Shift to the right. So I have to counteract this. You understand? So if I decrease C, the equilibrium will shift to where? the equilibrium shift to right.
Right.
So I hope you really understand. So that's what we discussed last week. But then for Igcse, when it comes to gas state, it applies other things. If you increase the pressure, it will shift to fewer moles. If you decrease the pressure, it will shift to more moles. So, for example, everything that I write here, you need to know, but depends. That if you plan to pass IGCSE, if you don't plan to pass, yeah, don't need to know. So let's say I give you these equations, right? This Haber process. Right? I will go slowly, but then you use your mouth to answer if you don't understand.
So may I explain those two sentences to increase the pressure
Yeah,
and
this one.
decrease the pressure. Okay.
And what do you mean by shift to fewer moles? The side that has fewer moles?
No problem. No problem, I'll explain. Okay, now I continue first here. So Haber process is to produce ammonia. So I want to ask you first, in the left hand side, how many moles of gases do you have? Hydrogen have 3 moles. Nitrogen have 1 mole. Ammonia at the right hand side is 2 moles. So the left hand side have how many moles? How many moles do you have at the left hand side? 4. Right hand side? 2. Okay, so if I increase the pressure, it shifts to fewer moles. Where's the fewer moles?
Right.
Forward, right? To produce more ammonia. So if the pressure is decreased, it will shift to more moles. Anyone wanted to ask questions until here? Not only that, so in Haber process, in IGCSE syllabus, you have to know the catalyst. The catalyst is finely divided iron, or you can just say iron. The pressure is around 200 to 250 atm, atmospheric pressure. Any questions so far until here? Any questions you guys want to ask until here? And then the temperature is at 450 degrees Celsius, or maybe your teacher say 400 Celsius also okay. But something right here is the enthalpy change is negative. So if the enthalpy change is negative, is it exo or endo? It's exo. So anything you feel weird until here? If exothermic, the temperature is supposed to be high or low in order for it to go forward. Temperature have to be low so it can go forward. The temperature have to be low so it can go forward. So if the temperature is high, can it go forward? No, it will shift backward. It will shift backward. Yes, any questions until here?
Sir, what do you mean by temperature is low? Surrounding temperature.
Yeah. I want to explain more about the Haber process. So you take a picture of this first and you have to pay attention. If no, you don't understand anything here. Okay, so what I'm trying to tell you is, in the exothermic reaction, if you lower the temperature, you will cause the equilibrium to shift forward. Because to make it to happen, right, you need a low temperature. So if you give a low temperature, it will shift forward. So the yield will be more. What about the rate? Understand rate? Yield is how much. Rate is how fast. If you keep the temperature low, can it be fast?
No.
No.
So the rate is slow. So let's go back to the Haber process. The Haber process, the purpose is to produce ammonia. So if you do business, you have to have a good yield, of course. You need to have more things, right? The production have to be more. But then you produce more things, well, it's on your next generation already, it will be useless, right? I mean, by the time of the production, the yield is done, and then the person passed away already. It will be too slow if you keep the temperature very low. The molecules barely can collide, right? You understand? And so we have to take the win-win solutions. So for the temperature problem, the temperature is 450 degrees Celsius. Right? If you're asked for the reason why, because this temperature is low enough for good yield and high enough to support the rate of reaction. So the temperature 450, that is counted low enough already. That's good enough for the yield already. But it's still high enough to support the good rate. So if you always decrease the temperature, then it will be too slow. Even though you have a very good yield, but it's useless. It will be too slow. Understand? Now you take a picture, you take a look at the picture that I asked you to take just now. If we increase the pressure, the equilibrium will shift forward, right?
Yeah.
So it's good, isn't it? Because you have more ammonia, right? But then if you keep on increasing the pressure, it will be explosive. So for that reason, even though you want a good yield, even though you want the pressure to be high to be a good yield, if you understand this thing, can you keep on raising the pressure? You make it higher and higher?
No.
No, it will explode. So this is the two questions that usually Igcse will ask. If I increase the pressure, how? It will shift to where? So if later he will bring it to Haber and then ask you why not keep on increasing the pressure? What happened to the temperature? What exos have to be like that? So you have any questions until here?
Sir, what do you mean by temperature is low if in an exothermic reaction? Does that mean activation energy is needed less?
No, but then to support that you have to have a low temperature in order for it to happen.
But can't you also have a high temperature?
Sorry?
Can't you also have a high temperature?
What temperature? I'm currently listening, I'm not very clear.
In an exothermic reaction, the top left one, if the temperature is low. Wait, never mind.
If the temperature is low, then?
Never mind.
The rest have questions again. I want to give you another example again.
Okay, right. Why does the equilibrium shift forward if the temperature is low?
Because the meaning of exothermic itself is what? Means the reaction is releasing energy, right?
Mm.
If the reaction is releasing energy, to support that, in order to allow it to release energy, then just keep the temperature low. If you keep the temperature high, well, he need to release the energy, right? Cannot, it won't work.
Oh, okay.
Just now someone is speaking, but I cannot listen because I'm answering given questions, right? Just don't have anyone ask questions. No, so I can continue.
Yeah.
Yeah.
Yeah. I want to give you another example again. So yeah. So let's say in the second example, I have 2SO2 plus. So I'm teaching you several, like Haber process. You need to know.
Haber is just for ammonia.
Yeah.
The heck?
These are all also in gas state. This process is called as contact process.
But isn't it the same thing as Haber? Just a different stuff.
Yeah, I will tell you this later. Later, I'll tell you the uses of this process as well.
Why do they have different names?
Sorry?
Is contact, why do they have different names? Haber is a person, right? How about contact? Is that a person name?
I'm not so sure. If it's a person, I never know is it a person. Okay, no, you see the things right? The temperature is 450, the pressure is 1 to 2 atm, the catalyst is vanadium V oxide. So this is also exothermic. So if I increase the pressure, what will it shift to?
Right.
Also right, because the right one have a fewer moles. The gas only 2 moles. Any questions until there?
Oh.
So what is the function of contact process? Contact process is needed to make sulfuric acid. Sorry, I don't try to complicate it, but everything of this is in the syllabus. So you have to know this. So after you have the sulfur trioxide, after you have the SO3, you have to do next is you add the SO3 with a concentrated H2SO4 first. So it's gonna be weird because you need sulfuric acid. You want to make sulfuric acid, but you need sulfuric acid. What does it mean? Did I explain? You want to make sulfuric acid, right? But you need to have a sulfuric acid at the first place. So how can that make sense? Did I explain? This one after you add it, right, it will be H2S2O7. We call this as oleum. After we have the oleum is added with water.
How do you spell that, sir?
Oleum.
OLEUM.
So if
Does
you
it
add
have
it with
an I?
water, it will become 2H2SO4.
Oh, that's a bracket.
You want to take a picture of this? I want to erase the left side, the first column. So if you see the SO3 just now, right? Actually, if you take SO3, if you take the SO3 and you add it with H2O directly, chemically will give you H2SO4. I mean, if we're from the atoms and the stuff, but this one cannot. This one, the reaction is two figures. So it's very explosive. So usually in Igcse, they ask you, why we cannot add SO3 with the H2O to give you H2SO4. If you do this in a big amount, like in the factory scale, it will be explosive. But then if you do it in a little bit amount, somehow it's still safe. But then for the factory scale, cannot, it's explosive, two figures. Now, so the reaction that I need to explain is, just now I say you want to make sulfuric acid, right? But I say you need a concentrated sulfuric acid. How can that make sense? How can I make a sulfuric acid with using a sulfuric acid? That is the question. You learn about electrolysis already, right?
Yeah.
So let's say I have a salt. I'm using electrolysis of CuSO4 aqueous. So at the positive plate, it will attract the OH negative. At the negative plate, what will it attract? Cu2 positive, is it? So where is the electrode that's left?
Four.
H2SO4. So you got sulfuric acid, right? So the sulfuric acid that you need at here can be taken from this. So the next question is, if you can do it in the electrolysis process, then why we need to learn contact process? Electrolysis is using electricity, right?
Yeah.
So the amount of energy needed is too much. The cost is also expensive. We want to set up the electricity. So usually we just use the electrolysis process to get a little bit amount of the concentrated of H2SO4, then we will carry to the contact process, right? So the production is in a greater scale. Any question?